This is topic 27, solving equations using inverses. So the type of inverses that we're going to look at today is the natural log of x and the log of x. So when we're using inverses, remember we use that opposite function in order to cancel it out. So for example, the inverse of natural log of x is going to be e to the x. So the inverse of natural log to the of x is e to the x. And then for log of x, the inverse of that is 10 to the x. So again, we're just using these functions in order to solve for x. So remember, they cancel each other out so we can get to x and then solve for the equation. So in the first concept, we're solving equations using natural log of x and e of x. So for example, on number 1, we have e to the 3x equals 12. So again, we know that in order to cancel out e to the x, we're going to have to do natural log to both sides in order to cancel out that e. So I'm going to take the natural log of both sides. Okay, and notice how I put each of those in parentheses after it, because I'm taking the natural log of it. The natural log and the e are going to cancel. So we're going to be left with 3x is equal to the natural log of 12. And then in order to solve for x, we're going to divide both sides by 3. So we get x is equal to the natural log of 12 over 3. And you can actually type that into your calculator. So I would type natural log of 12 in parentheses divided by 3, and you should get 0.83 as your answer. Either is acceptable. You can either leave it in terms of natural log or give me the decimal answer. Okay, so let's look at number 2. Again, number 2, in order to get that x out of the exponents, we're going to have to use the inverse function for e to the x. And the inverse function of that is natural log. So we're going to take the natural log of both sides. When we do that, the natural log and the e cancel. So we were left with x is equal to the natural log of 72. Or if we type that into our calculator, we would get 4.28. Again, either is acceptable, the decimal or the natural log. Okay. Okay, on example 3, remember when we were doing the notes previously, in order to first use those inverse functions, we had to get that function by itself. So for example, we have an e in our function here. So right here, this e to the 0.06t. We need to get that entirely by itself before we can do the natural log of both sides. So what I'm going to do first is I'm going to divide both sides by 50. Okay. So I have 250 divided by 50, which is 5, is equal to e to the 0.06t. Once I have that e by itself, just like I did in the first 2 problems, then I can take the natural log of both sides. So the natural log of 5 is equal to the natural log of e to the 0.06t. Remember, all that does is cancel out the e, and everything else gets brought down. So I have the natural log of 5 is equal to 0.06t. So in this case, we're solving for t. We have to get t by itself. So I'm going to divide both sides by 0.06. And I have t is equal to the natural log of 5 divided by 0.06. Typing that into my calculator, I get approximately 26.82. So the only difference between the first 2 and number 3 is that we had to get our e by itself first before we could take the natural log of both sides. So looking at number 4, same concept. Notice how we again have a 50 in front of our e. Okay, so I'm going to divide both sides by 50. 25 divided by 50 is 1/2. I'm going to go ahead and keep it as a fraction for now. So 1/2 is equal to e to the negative 0 point, how many zeros? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4 t. Now that I have my e value by itself, I'm going to take the natural log of both sides. So the natural log of 1/2 is equal to the natural log of this entire right side. When I do that, that is going to cancel out the e, and everything else is going to drop down. So I have natural log of 1/2 is equal to negative 0.0000124 t. In order to solve for t, I'm going to divide both sides by that really small decimal. Oops, I forgot a 0. There we go. And so I get t is equal to the natural log of 1/2 over negative 0.0000124. Or if I type that into my calculator, I'll get approximately 55,898.967. And again, either is acceptable. You can turn it into a decimal or you can leave it in the natural log format. I would definitely practice turning it into a decimal because in your next courses, you'll need to know how to do that on your calculator. But for the sake of the exam, I would accept either answer. Okay, now let's look at number 5. Okay, so same thing we were doing before. Our e is not by itself, so we're going to have to first divide both sides by 50. So I get 25 divided by 50, which is 1/2, is equal to e to the 15r. And then in order to cancel out e, I have to take the natural log of both sides. So I'm going to do the natural log of 1/2 is equal to the natural log of e to the 15r. The natural log cancels out the e. So I'm left with the natural log of 1/2 is equal to 15r. And in order to get r by itself, I have to divide both sides by 15. So I'm left with r is equal to the natural log of 1/2 divided by 15, or approximately negative 0.05 if you type in your calculator. Okay. So notice in all of these examples, we use the natural log in order to cancel e. In example 6, we already have the natural log, so in order to cancel that, we use its inverse, which is e to the x. So since my natural log is by itself, I'm going to go ahead and take this problem and make these values the exponent of e. So for example, I have e to the natural log of x is equal to e to 3.548. We did this because the natural log and the e cancel. So when they cancel like this, the x value that was in the exponent drops down. So we have x is equal to e to 3.548. And remember, e on your calculator is just a number. So if you type this on your calculator, you should get 34.74. Again, either answer is acceptable. Just know that since e is an exact number on your calculator, when you raise it to any power or multiply it by anything, you're just going to get another number. Okay, so number 7. So again, number 7 is in terms of natural log. That means in order to cancel it out, we have to use the inverse, which is e to the x. But before we do that, we have to get the natural log by itself. And notice that there is a 2 in front. So I'm going to first divide both sides by 2, and I get the natural log of 3x plus 1 is equal to 5. Now that my natural log is by itself, there's nothing in front of it, I'm going to take the e of both sides. So I have e to the power of natural log 3x plus 1 is equal to e to the 5th. Remember that e value cancels with the natural log, and I bring everything else down. So now I have 3x plus 1 is equal to e to the 5th power. And I'm solving for my variable just like I did in every other problem. This one just has a couple extra steps. So in order to get x by itself, I first have to subtract 1. So I have 3x is equal to e to the 5th minus 1. And then divide by 3. I get x is equal to e to the 5th minus 1 divided by 3. Or if you type that into your calculator, that is approximately 49.14. Last example for this concept. Again, we have natural log. So in order to cancel out natural log, we're going to use its inverse, which is e to the x. And notice there's nothing in front of our natural log, so it's already by itself. So I'm going to go ahead and take the e of both sides. Okay. Once I do that, remember the e and natural log cancel out. And I'm left with 4x minus 7 is equal to e to the 1. Remember, that first power of the exponent does nothing to the problem. So e to the 1 is the same as just saying e. So I'm just going to leave it as e. Now to get x by itself, I'm going to add 7. And I have 4x is equal to e plus 7. And then divide by 4. And I get x is equal to e plus 7 divided by 4. Or if I use my calculator, that's approximately 2.43. So that's it for the examples for the first concept. What I would do is I would definitely, and I should have said this in the beginning, I would, after every other problem or so, pause the video and attempt the next problem, just like when we do in class, and then see if you get your answer correct. And if not, go back and through my steps and see where you messed up. That's going to help you practice this last concept. And then again, do the same thing for this concept below. So the last concept here is solving equations using inverses, but now we're looking at log of x and its inverse 10 to the x power. So now if we see 10 to the x power, we're using log to cancel, or if we see log, we're using 10 to the x power to cancel. Okay, so let's look at that in some examples. So on number 9, we have 10 to the x is equal to 30. So since we have that 10 to the x, in order to get that x out of the exponent, we're going to use the inverse, which is log. So I'm going to take the log of both sides, just like I was doing in the concept above. Okay, the log and the 10 cancel. So I'm left with x is equal to log 30. Or if you type that into your calculator, that is 1.48. Okay, so all we're doing here is using these inverses that we already know in order to cancel out a function to solve for x. Number 10. So remember before I said that our logs and our e to the x's had to be by itself before I was able to take the inverse of both sides. Well, right here I have 10 to the x minus 4 equals 96. I need to move that minus 4 over to the other side in order to get my 10 to the x by itself. So I'm going to add 4. So I have 10 to the x is equal to 96 plus 4, which is 100. Now I'm going to take the log of both sides to cancel out that 10 to the x. Okay, so it cancels out that 10. And now I'm left with x is equal to log of 100. And if you type that into your calculator, you get 2. It's a lot of calculator work for this last topic. Okay, so now we have 3 times 10 to the x power is equal to 9. We need to have that 10 to the x power by itself, so I'm going to divide both sides by 3. So I have 10 to the x is equal to 9 divided by 3, which is 3. I need to get rid of that 10 to the x, so I'm going to take the log of both sides. And so the log and the 10 cancel, and I'm left with x is equal to log of 3, or if I type that into my calculator, that is 0.48. Okay. Now looking at number 12. Number 12, notice how we now have a logarithm instead of that 10 to the x. So that means in order to cancel out that logarithm, we are going to take everything that is in our equation, and that is going to become our exponent for 10. So for example, we have the log of x minus 2 equals 2. Log is by itself, so I'm going to do 10 to the power of log x minus 2 equals 10 to the power of 2. Okay. 10 and log cancel, so I'm left with x minus 2 is equal to 10 squared, which is 100. Add 2 to the other side, and I get x is equal to 102. That's my answer. Now let's look at 13. Okay, so 13, I have my log by itself, so I'm going to do 10 to the power of log 3x is equal to 10 to the power of 0. 10 and log cancel out, so I have 3x is equal to 10 to the 0. Remember, anything raised to the 0 power is 1, so that 10 to the 0 is actually equal to 1. So I have 3x equals 1, divide both sides by 3, and I get x is equal to 1/3. That's my answer. Okay. Number 14. So in number 14, we have 6,000 is equal to p times 10 to the 0.02 power. Notice how this 10 to the 0.02 power is just a number. There's no variable in there that we need to bring down, so there's no need to use the inverse here because we do not have an x or a variable in the exponents. Because if you type 10 to the power of 0.02 into your calculator, you're going to get a number. And that number is going to be 6,000 is equal to p times 1.05, so 1.05 p. That's what that 10 to the 0.02 equates to. Okay. Now we just need to get p by itself, so I'm going to divide both sides by that 1.05, and I get p is equal to 5,714.29. So again, I just typed this into my calculator. Okay, number 15, looking through my problem, I noticed that I do have this 10, oops, wrong thing, this 10 to the power of 0.05x. So I do have an x, a variable, in my exponents. So in order to cancel out that 10, I'm going to have to use the logarithm of x. But before I do that, I have to make sure that 10 is by itself. So I have to get rid of that 30 by dividing by 30. 600 divided by 30 is 20, so 20 is equal to 10 to the power of 0.05x. I'm going to take the log of both sides, so the log of 20 is equal to the log of 10 to the power of 0.05x. Log and 10 cancel, so I'm left with log of 20 is equal to 0.05x. Solving for x, I'm going to divide both sides by that 0.05. So I have x is equal to log of 20 over 0.05, or if I type that into my calculator, that is approximately 26.02. Okay, lastly, number 16. I have a 10 to the power of 3x, so I'm going to have to use the log to cancel out that 10. But before I can do that, I need to get rid of the 8 in front of it. So I'm going to divide both sides by 8, and I get 10 to the 3x is equal to 12 over 8. 12 over 8 reduces to 3 over 2. Then I take the log of both sides, so log of 10 to the 3x is equal to log of 3 halves. Okay. The log and 10 cancel out, so I'm left with 3x is equal to the log of 3 halves. Divide by 3 to solve for x, and I get x is equal to log of 3 halves divided by 3, or if you type this into your calculator, approximately 0.06. Okay, and that concludes these notes. If you have any questions on the notes, I am going to, again, have you post those questions in the discussion. I will go over those questions and answer them in video format if needed.